We are live. Okay, chapter 9. Estimation and confidence intervals. And this will begin on page 279. All right, what is a point estimate?
Statistic computed from sample information that estimates a population.
The statistic computed from sample information that estimates, I want you to underline that word, estimates the population parameter. All right, so remember, go back to that last chart. We use the sample mean to estimate something about the population mean. Now, we said that any difference between here, all right, we defined in the last chapter as sampling error. Let's build on that. On page 281, what is a confidence interval estimate? A range of values constructed from sample data so that the population data is likely to occur within that range of a specified probability. The specified probability is called the level of confidence. And your confidence interval is going to be equal to the point estimate plus or minus your margin of error. All right, now think about it. Your confidence interval, a range of values constructed from the sample so that the population parameter is likely to occur within that range. Okay, let's flip over. So basically, think about it. How confident, let's translate this. How confident are you that your sample data falls within this range of the population? And remember, we went back and said, in certain industries, you need to have greater confidence. Okay, so let's look at an example on page 285. And we are using as an example here, population standard deviation, known. So here's an example, and you're going to highlight these different examples of what data is given to you. So first, we're going to look at confidence interval for this example. Confidence interval, we're going to know the mean. Okay, so we know the population mean, and we're going to construct a confidence interval now. American Management Association is studying the income of store managers. Random sample, 49. All right, so 49 managers reveals, so our sample is 49, and reveals that a sample mean of 45,420. 45,420. The standard deviation is 2,050. All right. Now, what is the best point estimate of the population mean? Now think about this. What is the best point estimate of the population mean? Why do we take the sample to begin with? What are we gaining to learn something about? All right, in this case, we do not know what the population mean. We do know that the sample mean is 45,420. So is it not safe to assume if we had to just randomly guess, would you not guess that the population mean was equal to the sample mean? That would be your best educated guess. Your best point estimate is going to be what the sample mean is telling you. So your best estimate for the population mean is 45,420. Now remember, we're estimating that. Now it's asked, what is a reasonable range for values for the population mean? So since we're estimating it, what is a reasonable range that we would expect the population mean to fall within? And it tells us that the association decides to use a 95% confidence interval. So we just estimated the population mean was 45,420. And they tell us to estimate the values that we would be within using a 95% confidence interval. So what formula are we applying here? If you flip back to page 284, you see the confidence interval for a population mean with a known standard deviation. All right, so here we're going to apply what? The sample mean plus or minus Z. Work with me.
Z,
divided by the square root of n. All right, so what is our sample mean?
45,420.
So 45,420 plus or minus Z is 1.96. What's the standard deviation?
2050
1.96, is that bad?
on the table.
On the table from the last video, because it's one standard deviation. And our sample size was 49. Okay, now if we solve for that, you will get 45,420 plus or minus $574.
All right, is 95% always going to be that 1.96 for your Z?
And refer back to chapter 7 there. specifically page 216. So keep in mind, we're saying one standard deviation. So in this example, we're willing to, if this is 45,420, remember, we're willing to go one standard deviation to the left and one standard deviation to the right. So how many total standard deviations am I there?
9,
2.
2.
That makes sense. That's not where we have 1.96, but I'll find it.
Flip back to page 216.
See if I still see it.
The graph. 68%, 95%. 3 standard deviations. Nora?
99.7%.
99.7%.
So where do we get 1.96? I still don't understand. I see the percents.
Go back to your appendix in the back of the book. All right, one more example that I want to show you. If you flip over to page 289. Okay, 289. Let's look at an example with a population standard deviation unknown. All right, and I'm going to introduce the t-test. And what is the t equal to? Sample mean minus the population mean. All right, standard deviation divided by our n input. I'm going to give you a quick knowledge on when you're going to use the z-test or a t-test. Both are telling you like information. Whenever you know the mean and the standard deviation, you're going to use a z-test. When those variables are unknown, you're going to use the t-test. So we're going to say over here that when the mean and the standard deviation are known, what are you using? The z-test. When these are unknown, the t-test. All right, and let's look at page 292, and I'm going to give you an example.
mean and standard deviation.
Okay, tire manufacturer wishes to investigate the tread life of tires. And if you look at page 292, it's going to show you that chart that I just put up. All right, so a tire manufacturer wishes to investigate the tread life of tires. A sample of 10 tires driven 50,000 miles reveals a sample mean of 0.32 inches of tread remaining. with a standard deviation of 0.09 inches. Construct a 95% confidence interval for the population mean. Would it be reasonable for the manufacturer to conclude that after 50,000 miles, the population mean of tread remaining is 0.3 inches? Okay, so our sample size here, we pull 10. Okay, so we pull 10 tires that are driven 50,000 miles. And we see that we have a sample mean equal to what? 0.32 inches. With a standard deviation of 0.09. And then we're asked to use a 95% confidence interval. So would it be reasonable to conclude that after 50,000 miles, our population mean around the tread is 0.3 inches? Where do we begin?
Look at this chart. Plus or minus 2.262.
All right, so let's look at this solution. Do you know that this follows a normal distribution? No, but since the sample is, you're going to assume that the population distribution is normal. So you know that the sample standard deviation is 0.09. So since you have this, what formula are we using? So again, that the sample mean plus or minus T,
S over
what is S?
S is
Standard deviation over your n value, and what are you taking the square root of?
10.
There you go. Okay, so what is my sample mean? 0.32 plus or minus. Now where are we getting this t-score?
Yeah, it's from that graph. This is 95%. You look at the
Okay, now if you will flip back to appendix, the very last appendix in your book, you see the t-distribution. So wherever you had the z, flip over to the back side of that page, and you'll find the t-distribution. So at a 95% confidence interval, And I'm back on 292.
Degree of freedom.
All right, now I just heard the degrees of freedom are 9. How are we getting to the degrees of freedom? Our sample size was 10. Just know when you look at degrees of freedom, take the sample size minus 1. And we get and that on the back is Appendix B5, the book tells us.
It's 2.262.
Okay, so 2.262.
So you just said 2.2
And our sample size was 10. And if you solve for this, you're going to get 0.32 plus or minus 0.06. Okay, so in this case, endpoints of the confidence. So how do you interpret it? You would expect 190 of the intervals to fall within the population mean. And we are out of time. All right, dig in there. Remember, when they're known, you're going to use the z-test. When they're unknown, we're going to use the t-test. We're looking at confidence intervals. Draw the graph. Understand, plus or minus, we're on both sides of the mean. Go in there and work a couple problems. Let me know how I can be of help.
You said that this stuff we'll have it in the final project?
You will use one of these in your final project.